Hi everybody. Last time we finished talking about the Arrhenius definition of acids and bases, and we talked a bit about strong acids and strong bases and weak acids and weak bases. We also need some way of indicating how concentrated a solution is. You can have a strong acid but have very little of it, and the solution will not be very acidic, and same thing with bases. So the pH system is something that's used for people to measure how strongly acidic or strongly basic a particular solution is. As we learned last time, an acid is a substance that produces hydrogen ions in water, and a base produces hydroxide ions. It turns out that water itself can actually dissociate, just as acids and bases do. So when water dissociates, it produces both a hydrogen ion and a hydroxide ion. So could we classify water as an acid? Yes, we can, because it meets the definition of producing hydroxide or hydrogen ions. We can also classify water as a base because it produces hydroxide ions. So water is actually both an acid and a base. Mathematically, the pH is defined as the negative log of the hydrogen ion concentration. So those brackets around the H plus simply means the concentration of the hydrogen ion in the water, and the units of this are moles per liter. We haven't actually learned about moles yet, so don't worry about that. Just accept the fact that the mole is a certain amount, and so the greater the concentration, the greater that number will be. To calculate the pH, you simply put in the hydrogen ion concentration in your calculator and then press the log button. And I will make a little video later on to show you how to do that on your own calculator. Once you've done that, you simply change the sign to make it the negative log, and that's your pH. When a water molecule dissociates, since it's splitting in half, you're going to get an equal amount of hydrogen ions and hydroxide ions. In the case of water, it dissociates only a very tiny amount, so you get 1 times 10 to the minus 7th moles per liter of both hydrogen ions and hydroxides. That's like about 1/10 millionth of a mole. If you take the negative log of the H plus concentration, the 1 times 10 to the minus 7th, we end up with a pH of 7. A lot of you may be aware of the fact that a neutral solution has a pH of 7, and this is why, because the hydrogen ion concentration in water just happens to be 1 times 10 to the minus 7th. It's not a coincidence that the exponent and the pH are the same. Anytime the amount of hydrogen ion is 1 times 10 to some power, then the pH will be whatever that exponent is. If the coefficient is not 1, then it will be different. Vinegar contains acetic acid, and thus the hydrogen ion concentration will be higher than you would find in water. So keep in mind that with negative exponents, the smaller the number, the greater the value is. So 1 times 10 to the minus 4th power is actually 1,000 times bigger than 1 times 10 to the minus 7th. So if you take the negative log of the 1 times 10 to the minus 4th, we get a pH of 4. Ammonia is a cleaning product, and thus it's basic. So the hydrogen ion concentration in ammonia is less than 1 times 10 to the minus 7th, while the hydroxide concentration is greater. Again, if we take the negative log of the H plus concentration, since it's 1 times 10 to the minus 11th, the pH is simply 11. Okay, unlike pure water, tap water contains a number of different chemical compounds, and therefore its pH is not exactly 7, and it's not perfectly neutral. So if our tap water has an H plus concentration of 3.5 times 10 to the minus 6th, we can't simply take the 6 and make that the pH. We'll actually have to plug that value into the calculator and take the log of that, and if you do, you'll come up with a pH of 5.46. Since 3.5 times 10 to the minus 6th is greater than 1 times 10 to the minus 7th, it should be an acidic pH, and 5.46 is a bit on the acidic side.
All right, now let's use our tap water example, and I'll show you how to put that information into the TI-30XA calculator and figure out your pH. If you have a different calculator, it'll work fine. So on this one, the first thing we do is enter our coefficient of 3.5. Now on this calculator, to get exponents, we use the double E key right here. If you hit that, you'll notice that an exponent box appears. Some calculators have an EXP key instead of EE. It just depends on the brand. Now we can put in our exponent of 6, but since we want it to be negative 6, we'll hit this plus minus key here, and now it's become a negative 6. And then we simply hit the log button, and we get negative 5.46 if we round off to the hundredth. Since the pH is the negative log, we're going to change that sign, and now we get a pH of 5.46, which is exactly what we came up with previously in our lesson.
Determining whether a solution is acidic, basic, or neutral is pretty straightforward. Since 1 times 10 to the minus 7th is neutral, anything greater than that will be acidic. Conversely, if the H plus concentration is less than 1 times 10 to the minus 7th, then the solution is basic. Since the H plus and the OH minus concentrations are linked, we can also determine whether something is acidic, basic, or neutral from the hydroxide concentration, but it's simply the opposite. So if the hydroxide is greater than 1 times 10 to the minus 7, then the solution is basic. And of course, if the hydroxide concentration is less than 1 times 10 to the minus 7, the solution will be acidic. So whatever is true for the H plus, the opposite is true for the hydroxide. So an H plus greater than 1 times 10 to the minus 7th is acidic. So a hydroxide greater than 1 times 10 to the minus 7th is basic. So just to recap what we've covered here, in pure water, the H plus and the OH minus are both 1 times 10 to the minus 7th, giving us a pH of 7, so it's neutral. For the vinegar, if we look at the H plus, it's greater than 1 times 10 to the minus 7th, which tells us it's acidic, and the hydroxide concentration is less than 10 to the minus 7th, which tells us it's also acidic, and of course the pH of 4 tells us the same thing. For the ammonia, an H plus of less than 1 times 10 to the minus 7th tells us that it's a basic solution, and the hydroxide concentration of more than 1 times 10 to the minus 7th also tells us it's basic, as does the pH of 11. And then finally, for the tap water, the H plus is greater than 1 times 10 to the minus 7th, making it acidic. The hydroxide is less than 1 times 10 to the minus 7th, also telling us it's acidic, and of course the pH is less than 7, again confirming that it's acidic. There is another way that one can determine whether a solution is acidic, basic, or neutral, and that's called the pOH. It's very similar to the pH, but we simply take the negative log of the hydroxide concentration instead of the hydrogen ion concentration. So for pure water, the pH and the pOH are actually the same, since they're both 1 times 10 to the minus 7th. For vinegar, the pOH is based on the 10 to the minus 10th, so it's a pOH of 10. For ammonia, the pOH would be 3. And for the tap water, we have to use our calculator and plug that in, and we come up with a pOH of 8.54. Two very important things to notice. You may have realized that if you add the pH and the pOH, in each of the four cases, it always adds up to 14, which means if you know one of them, you automatically know the other. And the other thing you may not have noticed is that if you multiply the H plus concentration times the hydroxide ion concentration, it always comes out to be 1 times 10 to the negative 14th. So again, if you know one of these, you can simply figure out the other one. So the pH scale is the most commonly one that's used, but the pOH scale will tell you exactly the same information. All right, let's try a few practice problems now to see what you guys have learned. So why don't you pause the video for a few minutes and work through these, and then we'll come back and figure out what the answers are. All right, let's see how you've done on these. For the first one, the hydroxide concentration is greater than 1 times 10 to the minus 7th, so that means it's a basic solution. And if we calculate the pOH, a pOH of less than 7 also means basic. For the second one, the H plus concentration is less than 1 times 10 to the minus 7th, so less H plus means less acidic, therefore basic. And the pH is a little bit greater than 7, also telling us it's a basic solution. For the third one, if the OH and the H plus are equal, it's neutral. If the H plus is greater, it's acidic. And if the OH is greater, it's basic. And in this case, since the H plus is greater, that means it's acidic. With the pH and the pOH values, we know the two of them have to add up to 14. So if the pH is greater than the pOH, that means the pH would have to be greater than 7 and the pOH less than 7. For example, it could be 8 and 6 or 9 and 5. So a pH greater than 7, of course, means basic. Grandma's chicken soup, food products are normally acidic, and of course Grandma's chicken fat soap. Soap is a cleaning product, and cleaning products are invariably basic.